Okay, let's start. Welcome to AWS and our React Meetup. So as you see, AWS just moved here. It's, I think, the third week that they have this room. So we sorted out some technical problems. Now we're still waiting for the registration. And we brought some additional chairs. So I think we're ready to go. And I'm especially happy to have Nader Dabit here. So we met at React Europe, and I invited him here, and I'm so happy that he could come.
Yeah, it's nice to be here.
And it's also great to have this venue here at AWS. Markus Kaiser is still at the entrance letting people in. But thanks, Markus, for opening the door for the participants. And Nader, I hand it over to you.
Yeah.
And we'll just kick it off. And we probably won't have time for too many breaks now. But I think every half an hour we'll have a break that you can get some food or drinks.
Yeah, I think so. Yeah, we'll take 5 minute, maybe 5 to 10 minute breaks where people can use the restroom, and also I can maybe walk around the room and catch people up. That way I don't have to stop as we're going. So thank you for the intro. My name is Nader Dabit. If you want to follow me on Twitter, that's the only requirement for this workshop. So twitter.com/Dabit3. Yeah, so that's me right there. And we're going to be going over this workshop. I've been working with AWS now for about 1.5 years. I'm a front-end developer. I'm a mobile developer. I don't consider myself a cloud developer up until 1.5 years ago when I joined AWS. I'd actually never used AWS when I started there. I was more hired for their mobile team, which now has become the Amplify team. And our entire team does nothing but build tools for mobile and web developers. So we're really all about JavaScript. We're all about native iOS, React Native, all of these things. We're only building tools that allow people to kind of get up and running with these full stack applications using their existing skill set. So everything we're going to be covering today is really just JavaScript. And everything that we build is focused towards front-end developers. It's not focused towards cloud developers. I think that makes our team very unique in AWS. We don't really speak the AWS like lingo. We have a different culture and everything. So about me, real quick, I've written a book on React Native called React Native in Action, and I'm also writing a second book right now that's available through O'Reilly called Full Stack Serverless. Full Stack Serverless touches on some of the stuff we're going over today, but also goes into depth around authentication, protected routes, storage, a lot of more complex stuff than what we're going to cover today. What we're covering today is mainly focused around GraphQL. We're going to also cover a little bit on authentication and authorization. But it's really kind of a GraphQL thing that we're going to be focusing on today. So yeah, to get started, we're going to be just reading over this workshop. All this is a GitHub README. All this really is a tutorial that I'm going to be walking you through. If you feel I'm going too slow, feel free to go ahead and finish this thing in 1 hour if you can. If you feel like I'm going too fast and you can't keep up, you can actually take this home and work on it over the next couple of days. You can message me and ask me questions in the next couple of days if you have any questions while you're doing this. I don't expect everyone to keep up. I don't expect everyone to go as slow as I'm going. Just kind of go at your own pace. And if you have any questions, I'm going to be taking little breaks in between and answering questions. So yeah, first of all, thank you for coming, and thanks for everyone that's helping host this. It's a pretty big crowd for a workshop. I typically do workshops that are 20 to 30 people. And this is much bigger. Workshops are a little bit more hands-on than a lot of the other things that I do, conference talks. So we end up having a lot of questions that need to be answered. People run into roadblocks. I ask of you if you have experience doing any of this stuff and your neighbor has a question and you feel like you can help them out, I would appreciate that. But if you can't answer the question, I'm going to, again, be taking little stops throughout this and helping you get started. One cool thing that we added with Amplify that we're going to be doing today that I've never done before in a workshop is using our local testing environment. We've built one of the first local GraphQL testing tools that I know of for serverless GraphQL APIs. I don't think anyone else has that. And it's really nice because you can actually play around with a bunch of different GraphQL schema and schemas. You can change things like adding authorization and authentication parameters and protecting fields. You can do connections. You can create different keys on your database and all this stuff locally without having to create anything in your account. So the only thing that you're going to be required to do today that's going to be actually creating a service in your account is going to be when you initialize the Amplify project, it's going to create an S3 bucket in your account. When you run Amplify delete after this, it's going to delete that, so that's going to be gone. The only other thing other than that is we're going to be adding authentication, which creates a Cognito authentication service in your AWS account. Cognito is something like Auth0 or Okta, if you've ever used one of those. And every time you create a new group of users, it's called a Cognito user pool. That's for an application. You get up to 50,000 users for free, so you don't have to worry about that costing you any money. But again, if you run Amplify delete at the end of this, it'll tear that down. But think about if you're prototyping and you want to create a bunch of different versions of your app. Every time you create a new pool of users, every time you create a new authentication service, essentially you have 50,000 free users. So it's really hard to get past that limit and actually get charged for anything there, unless your app has over 50,000 users, which is a really good thing anyway. So let's go ahead and get started. What we're going to be doing is, first step is creating a React app, which I'm sure everyone here is familiar with. And second, we're going to be installing Amplify libraries locally and whatever other local dependencies we're going to need. Third of all, we're going to be then creating and installing Amplify as a global on our CLI. I think a lot of the people that got here early have already done that and been able to configure their CLI. If you haven't, I am going to walk through that. So after we install the Amplify CLI, we're going to configure it, and then we're going to run a new Amplify project within the React app. Once we're done with that, we can actually then start creating services. So for anyone else coming in, yeah, I think we have some extra chairs over here. And for anyone else that didn't already hear this and that is coming in late, everyone here is going to be given $15 credit for the AWS account and also some stickers. If you didn't get any stickers because you came in late, come find me whenever we're done, or just come during one of the breaks. I'll give you some. All right, so I'm going to be going along with you on this workshop. And really, if you get lost, you can literally just copy and paste everything from here step by step, and you should have a working project. I just tested this thing out a few hours ago. Everything seems to be working. So you can create a new React app by using create React app, having the global installed, using this step here, or you can use npx. I'm going to use npx. I'm just going to copy this line here and create a new React app using npx. The app that we're going to be building today is a conference app, and we're going to be starting with adding a way to add, or like a Meetup app, you could think of something like that, where you have talks. Each talk has like a speaker and a name of a talk and things like that. We're then going to add a way to add authentication to that app. We're then going to add a way to have comments. That way you can comment on the talks. And then we're going to add authorization. So not everyone logged in can actually create a new talk. You have to be an admin. So we're going to add different security rules and stuff around it. And that's about it. I think we might also have time to go into where we create Lambda function resolvers for our GraphQL API. And that way you can actually do a bunch of other stuff. But the thing that we're going to go over is how to interact with a REST API from GraphQL, which is really cool. It's a really good technique for porting over REST APIs to GraphQL. So after we create the React app, I'm just going to go ahead and change into this. And we're going to go ahead and install all of the dependencies we need. The dependencies that we're going to be working with are AWS Amplify React, and UUID. You can just paste one of those commands using either yarn or npm. So the three libraries we installed, you may have used UUID. It does what you think it does. It just creates a unique ID. You've probably used it before. You've seen it. AWS Amplify is the core JavaScript library behind Amplify. You can use Amplify to do everything just using this one JavaScript library. We also add an additional optional library called AWS Amplify React. This library adds different components that you can use that are platform specific. We support React, React Native, Vue, Angular, Ionic, hopefully Svelte soon. And Svelte fans in here? There we go. But right now we don't, but it's coming. We just talked about it today. So we're going to be using the AWS Amplify React library only one time today. That's to scaffold out a authentication flow. So after those components, after all that stuff has been installed, we're going to now install and configure the Amplify CLI. After that, we're going to initialize a new Amplify project. And then after that, we're going to take a little break because I think that's going to be a part where some people might run into some issues. So to install the CLI, we run npm install -g at AWS Amplify CLI. So I'll go ahead and copy this, and I'm going to go ahead and run it. This should put you on version 3.0, which was released a couple of days ago, maybe a week ago. Any questions while my CLI is installing? I already have this installed. I'm just running it again to make sure I'm on pace with everyone here. All right, so I think a lot of people may already have this installed anyway. If you didn't, then that step should have maybe kind of been finished by now. I'm going to keep on going. If you get behind, again, we're going to be taking a break just in a second, and you should be able to catch up. But after we install the CLI, we're going to now configure the CLI. What this does is it sets a user that you can then create AWS services on behalf of. I already have a bunch of different users configured with my CLI, but I'm going to go ahead and create another one for this workshop to kind of walk you through how to do that. Every time you run Amplify configure and you add a new user, you'll then just have another user to choose from. Typically what people do is they'll have different users for different regions or different users with different permissions. So Amplify configure, we'll go ahead and run that. This should walk us through these steps here. And you should have already signed into your AWS account. If you haven't, it will open your AWS page for you to go ahead and sign in. So you need to be signed in after this step here, and then you go back to the CLI. So you run Amplify configure, it opens the AWS console, and you can jump back to the CLI. Here, we're going to now specify the region. I'm going to go ahead and choose EU Central 1. You can choose whatever region. This is probably the best one for here. I think this is Frankfurt. Then we're going to go ahead and set a username. This is going to be the username that we're going to create this user in the AWS account. So for this step here, I'm going to go ahead and choose this exact user that I have listed here so we can all be on the same page. Amplify workshop user. This could be whatever you'd like it to be, really. So this should go ahead and open up the IAM, which is the Identity and Access Management Dashboard in AWS. You can just accept everything, just click next, 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 whatever. I'm going to walk through this real quick though. This is just populating the username field with what we filled out in our CLI. There's two types of users that you can create, either or and. You can either do programmatic access, which allows access from different SDKs. You can do the console access, which means the person that you're creating this user can actually log in as a person on the AWS website and create stuff in the console, or you can allow both. I would recommend just leaving it as is with programmatic for this user. Next, you have the option to update the different policies that are associated with this user, the permissions policies. For Amplify, we end up doing a bunch of different things. So we end up using admin access, which allows the CLI to create all of these different services that we're going to be using. We click Next, and then we just click Next Review, and then Create User. And this will go ahead and give us our access key ID and our secret access key, which we're going to need in just a moment. What we do is then copy this access key ID over to the command line like this. And we paste that there. And when you hit enter, it'll then prompt you for the secret access key. So I'll go ahead and do that. And then now we're going to give this a profile name for the local reference to this user. The username that we used earlier is the username that's going to be in your AWS account. This is going to be the user referencing that account or that user from your local machine. I recommend using the same name. That way you know what is what. So I'll just copy this over. And then this will set up a new user. Where does that user live? Well, if you go to .aws, you should now, I think it's .aws. Yeah, if you go to .aws, you should now see a config and a credentials file. Credentials has the access key ID and the secret access key with the name, and then config has the region and the name, and then they're associated from there. So if you're wondering like where that stuff is stored, if you want to delete it later, that's where it is. And if you've ever used the AWS CLI, it might already be there. So now we're done with that. We can now go back to the workshop, and we have everything we need now to amplify init. So we're going to run amplify init. This creates a new Amplify project wherever you are willing or needing to work with this. Typically, you'll do this at the root of your mobile app or your web app or whatever you're working with, and that's what we're doing here. So we're going to run this in the root of our React app. So amplify init. This is just going to walk us through a few different steps. We're going to give the project a name. I'm going to go ahead and copy everything from the workshop. You can do whatever you want. Amplify React app. The name for the environment, we support multiple environments, so we're kind of creating a base environment. If you want to then create some new functionality, but you don't want to affect your main environment, you can then amplify, check out env check out a new environment based on this base environment. So I'm going to go ahead and give this environment a name of dev. You can go ahead and choose your Visual Studio Code or whatever you're using for your text editor. And then now the CLI should recognize that you're in a React app, and then everything else should be auto-generated if you're in a Vue app or an Angular app or a native iOS or Android app. So it should automatically say we're in a React JavaScript with React as the framework. It should detect the source, the build directories, and all of these other scripts. So you can kind of just hit enter, 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 all the way through. And then now it's going to take us to using the AWS profile that we just created a second ago. So we need to now use an AWS profile or choose no and run through those other steps again. I would recommend just choosing yes since we already have one. And this will prompt you with the list of all the profiles that you have in your machine. So I'm going to go ahead and choose the Amplify workshop user. And then this will initialize the Amplify project, which will allow us to then go and start creating services. So this is going to be our first break. So because this is usually a step that kind of, for some reason, because a lot of times people have different issues with NPM or Node, or maybe this is their first time using AWS, we might run into some issues. So we're going to take a 10-minute break here. So we're going to start back at 10 minutes after the hour. And if you feel like going ahead and doing that, that's fine. If you want to wait, that's fine too. So I'll go ahead and walk around and answer any questions. Yeah. All right. So we are going to go ahead and move on to the next step. And what we're going to do now is we're going to create a new feature, which is basically going to be the API. So to do that, we're going to need to go ahead and first configure our React project to recognize the Amplify project that we just created. So if we go into our project, we're going to now see that we have a Amplify folder. And in this Amplify folder is going to be a backend folder. And this backend folder is where we're going to be writing code in the future that will be our GraphQL schema. And if we end up adding like Lambda functions and stuff like that, that's going to go in that backend folder. But for now, we don't really have to touch it or anything like that. It's just good to know that it's there. The current cloud backend folder is a copy of the backend folder, but it's the current representation of what's been deployed from the point of the last time you ran a push command, which is something we're going to look at in just a second. The push command takes the backend folder and deploys anything that we've changed up to the AWS account. And then at that point, after you run Amplify push, the backend folder in the current cloud backend will be in sync. If you then make changes to backend, then they'll be out of sync until you run Amplify push, then they'll come back in sync. It's just a way for us to have a representation of what's currently been deployed for diffs. You'll also see in the source folder that we have a new file called AWS exports.js. And if we open this file, we'll see that right now we only have a object with a single property called AWS underscore project underscore region. This is the region based on the user that we used when we ran Amplify init. So we see that it should be the same region that we created that user. And then this file is nothing we have to actually touch or change. This will be updated by the CLI as we add different features and things like that. So we're going to be adding GraphQL API in just a moment. After you add the GraphQL API and run Amplify push, we'll see that this file has been updated. When we add authentication, we'll see that this file has been updated again, and so on and so forth. We don't actually write to this file, but we do reference it. And you're going to see in this next step, we're going to need to now reference this file to configure the project based on what's in that file. So we can now go ahead and open up source/index.js. And underneath the last import, we can now add these 3 new lines of code. We're going to import the Amplify library. We're going to import that configuration file, and then we're just going to call amplify.configure. We're doing this at the root level at source/index.js. Once this is done, we can now start using everything that is in our Amplify project that we're going to be then creating in just the next step. So I'll go ahead and open this up in my text editor. And I'm just going to paste these 3 lines here. And that's all we have to do now. So after we've done that, we're kind of good to go. We can continue on to the next step. So we just pasted the import amplify, import config, and amplify.configure, and index.js under the last import. All right, so now that we have our React app ready to go, we're going to now add the first service that we want to add. So we want to add an API. We want to add a GraphQL API. So to do that, we can run amplify add API. The way that we add features is we run amplify add and then the category of the feature. What's different about Amplify from other AWS tools and services is that we don't need to know all of the stuff about the service backing it at this moment. You can go ahead and create things based on what it's about to do for you. So for instance, we don't say we want to add a Cognito user pool. We say we want authentication. We don't say that we want to add a Lambda function and API gateway and all the code and all the shit that goes along with that. We just say we want Amplify add API. That way we can kind of abstract away a lot of the verbosity of what AWS kind of is. So when you add an API, you have the option of adding three different types of APIs. You can add a GraphQL API, which is AppSync. AppSync is what we're going to be using today. It's a managed GraphQL as a service, something like Firebase, but for GraphQL. You could also add 2 different varieties of Lambda function with API gateway. When you create a Lambda function, a serverless function, you have to have a way to invoke it. AWS is, or Lambda in general is kind of part of an event-based architecture typically. And the way that you can invoke a Lambda function can be a variety of different ways. The most popular and what people use when they talk about it a lot of times in our world, the front-end world, is invoking this Lambda function from an HTTP request. And you can do that by using something called API Gateway. But again, since we don't really want to know or care about all that stuff, we can run Amplify add API. It'll actually just wire up the HTTP endpoint with the Lambda function. We can then just write the function code and then invoke that, given the URL that's generated for us. So, but again, we're not going to be really going over creating APIs with Lambda today. We're only focusing on GraphQL. So let's go ahead and run this and see all the steps that we are taking through. So we're going to run Amplify add API. This will go ahead and prompt us. We want to use GraphQL as the type. We're now asked for the name, and I'm just going to call this Conference API. We can now choose either API key or Amazon Cognito user pool. For now, we're just going to choose API key, and we're going to update this later when we add authentication. The API key just means anyone with the API key sitting in the header can access this API. Do we have an annotated GraphQL schema? If we did have a schema we wanted to use, we could just say yes and reference that location of the file. But since we don't, we're going to choose no. And then we have the option of a guided schema creation. This is essentially just a set of blueprints or a boilerplate GraphQL schemas that you can start with. So let's go ahead and choose yes so we can kind of see what's available. Since we don't have authentication enabled, we only have two. If you have authentication enabled, you also have an example with authentication and fine-grained access control or authorization. So we can either do a single object with fields or one-to-many relationships. It really doesn't matter at this point because we're going to be overriding this anyway. But we'll go ahead and choose one or the other, and then we can choose yes to go ahead and edit the schema. And when we do that, this should go ahead and open up the GraphQL schema in our text editor. And it shows the path of where this schema is going to live here. So if it doesn't open for you, for whatever reason, it should. But if it doesn't, this location is where that schema lives. And what we are started with is a really basic GraphQL schema with just a single type with 3 fields. But we want to do a conference app. And this is the type that we're going to start our app with. It's going to have an ID field. It's going to have a client ID field. This way, when we create something from our client, we can know who created what. We're also going to have a name for the talk, a description of the talk, the speaker's name, and the speaker's bio. So we'll go ahead and copy that and paste it here. One thing you'll notice that's a little different from a typical GraphQL API is that we have this @model directive. @model is part of the Amplify CLI's GraphQL transform library, which has 7 different directives. @model is one of those 7 directives. @model will take a base type and generate an entire GraphQL API based on a bunch of best practices and assumptions. So you can assume when you're creating an API that you want the CRUD and list operations that you would need for most APIs. So you want a way to create a talk, update, delete, all of those things. We create all of the schema, all of the operations for you when you use this @model. We also assume that you want to have subscriptions based on any events. So anytime you create, update, or delete a talk, you might want to have a subscription for that. We go ahead and create the subscriptions for you as well. We also assume that you need a data source. So when you use @model, we create a NoSQL database for you. And then we also create the resolvers that map between all of those operations. So whenever you create a GraphQL API, you typically have to write the resolver for creating something, the resolver for updating and deleting. We make all of these assumptions because it's just a lot of boilerplate that you don't have to write. You can then go and modify that with any business logic that you'd like, or you can continue modifying your schema based on these other directives that we have that we're going to go over later. We also have, what we're going to go over today is @model. @auth allows you to add authorization rules. And we also have @connection, which allows you to model relationships, one-to-many and many-to-many relationships between items. But for now, we're just going to go with @model, and we'll go ahead and save this. And we'll go back to the command line, and we'll hit enter. So if your schema is modeled correctly, it should compile successfully, and you should get this message. So what you could do if you wanted to deploy this is run Amplify push, but we don't want to do that yet. You could do that if you want to, but we might want to test this thing out and make sure that we like it before we deploy it and have to do anything different. So what we can do now, this is a feature that we added just a couple of months ago, is we can actually mock all this locally. And this will run a graphical editor locally. It'll mock the server, and it'll also allow us to use a in-memory database, SQLite. So what we can do is basically have the graphical editor open, create mutations, subscriptions, all of these different things, queries, without having to create anything in our account, which is really nice. So let's go ahead and run Amplify mock API. And we'll go ahead and test this thing out. This Amplify mock API is going to now look and introspect our schema and walk us through a few different steps. So what it's going to ask us if we would like code generation for our local project, because all of the operations that we need to use, if you're using those from the client, you need to have a definition for those. So we can either generate these in TypeScript, Flow, or JavaScript. I'm going to go ahead and choose JavaScript. We can choose the name and the location of the files that we're about to generate. I'm going to go ahead and choose the default because that's exactly where I want them to live. We already have this src directory. So we're now going to have a new directory called GraphQL, and we're going to now have a /mutation/subscription/queries.GraphQL, I guess, files there. So we have that. Now we can choose how deep we want these operations to go. I think 2 is, actually it's going to ask us if we want everything created. We'll go ahead and choose yes. And then how deeply nested is what we want. We'll go ahead and choose the default for that, which is 2. So that's going to go ahead and mock the API, and we should now be given an endpoint that we can test locally. So I'm going to go ahead and open that endpoint, and we see that we have a graphical editor here. And something that's cool that we implemented is if you've ever used OneGraph is a really, really nice GraphQL service that allows you to kind of implement GraphQL APIs on top of traditionally REST APIs. So they have all of these different ways to do things like Twilio and all this other stuff. We worked with OneGraph to actually use they had some really nice developer experience built in. And over here, we can see that we can add different operations without actually having to write them out ourselves. So what we want to do is we want to go ahead and first create a mutation because we want to query for things in just a moment. But in order to query for those things, we need to have something there. So I've already written out a few mutations. You can use these or you can write your own. For the sake of time, I'm just going to go ahead and copy these and use them here. So I'm going to go ahead and create our first mutation. I want to go ahead and create a talk. So I'll go ahead and paste that there. It just has some information about the talk. And we go ahead and click that. And now we see that the mutation is successful because we returned an ID, a name, a description, speaker name, and speaker bio. You might wonder where this ID came from, considering we didn't pass that in as an argument. The resolvers that we automatically generate detect whether or not an ID has been passed in. If there is an ID passed in, we use that ID. If there isn't one, we automatically generate one for you on the server. That way, you don't have to pass one in if you don't want to. I'll go ahead and create one more talk. So now we have one talk about React and one talk about GraphQL. So we created those 2 talks. Let's go ahead and query for these talks. So I'm going to go ahead and actually, instead of pasting that in, I'm going to go ahead and use the editor over here on the left. So I'm going to click Add New Query. I'll go ahead and click List Talks. I want to get the items array back. I want to return the description, the ID, the name, the speaker bio, and the speaker name. So as I'm selecting these, we see that the fields get populated. So I can go ahead and run my query. And we now see that we have those items come back for us. So we're actually referencing those items from our local database, and they are there. The next thing we might want to do is have some type of search capability for this list. So we might want to only search for talks that have a certain speaker or a certain topic. So we can actually pass in a filter, and the filter can be on any of the fields. And any of the filters can be one of about a dozen different types. So you can do operators on contains, begins with, greater than, equal to, a lot of mathematical stuff. So it's pretty nice for different data access patterns on your GraphQL API, because begins with allows you to do something that's pretty interesting in the NoSQL world, where you can have these composite keys is what they call them, where you add different fields onto a key so you can have different query ability on a single field in your database, basically compounding that query as you go. It's kind of hard to show without actually going into it, but it's a really powerful thing. So what I'm going to do is I'm going to go ahead and create a new query called list talks with filter, and maybe I only want to see the talks about GraphQL. And it looks like I have GraphQL on both of these, so let's go with React. So we see that when we run the list talks with filter, we only get the React talks back, but if we run the query, the regular query, we get everything back. So the filter is working and all that stuff is good to go. And now we might want to use this new API in our React app. So since we have this mock server already running, we can actually talk to this server just like if it was a live server. We can actually talk to this thing from our React app. So what I'm going to do is I'm going to go to our project that we have here, and I'm going to go ahead and open up our AWS exports file. And what you're going to notice is that while this mock server is running, we actually have that HTTP endpoint referenced in this file. When we stop that server, this file gets updated. So whenever we're running the server, we can actually basically be referencing that from here. Just something to note. So let's go ahead and go to the next step, which is going to be interacting with the API from our client app. So what we want to do is, since we have a couple of talks already there, let's go ahead and query for those talks and have those listed in our app. And we're going to be working with hooks in here. And if this is your first time working with hooks, then that's great. But even if you've used it before, we're going to be going over some basic stuff with hooks and also some advanced stuff. When I say advanced, I'm really talking about reducers. So who here is already using hooks? Okay, cool. So that's perfect. A lot of people have using it. A lot of them aren't using it. So the good thing about this is you can literally just copy and paste this code. It's going to work. You're not going to get too lost. But I will try to go over exactly what's going on real quick. The three hooks we're going to be using are use effect, use state, and use reducer. The first one we're going to be going over is using the query. And here we're only going to be needing use effect and use state. Use state is just using state, just like it sounds. Instead of using set state and update all this stuff, we're going to be using using use state. And then use effect is essentially component did mount. And use effect essentially just runs on the component mounting. And then it also will optionally run on update. So it could be a replacement for should component update. So we import those hooks and we import React, okay? And I'm going to walk through this code before I copy it just so we actually know what's going on. We then import our query from GraphQL. If you remember when we created this API locally, we told our CLI we wanted to have that GraphQL code generated locally. So you'll now see that we have this GraphQL folder here, and you'll see that we have all of these different operations created for us. So we don't have to write any of this code. It's all there for us. So now we can just import it. So that's pretty nice. So we're importing the code that's already there. We then import two operations from AWS Amplify, or two APIs, I guess. One of the APIs is called API. So that's one of them. API can be used to talk to API gateway or AppSync. So you can call different types of methods on this API. So I hate saying that. Anyway, so you can call API.get, API.put, post, delete. You can also call API.GraphQL. So that's what we're going to be doing. If you've ever used Apollo, you might have used GraphQL tag, or you might have used something like GraphQL tag, which basically takes a GraphQL operation and turns it into AST. And that's what we're doing here also. We have something called GraphQL operation, which allows us to take this query and wrap it in a function, and then it just works. We don't have to do a lot of extra work. So those are the imports. Before we render, we're going to be running through these three things here. We're first going to create an empty array in our state called talks. So talks is going to be equal to this empty array. We do that by calling useState, and useState returns a piece of data, and then it also returns a function that can change that data. So the function that we're going to be returning is we're going to call this update talks. You can call this whatever you want. We're going to be returning the talks array, which is empty, and then update talks to update that empty array. UseEffect or component did mount will be triggered when this renders. And what we do is we call a function called getData. And this is going to be when we're interacting with the GraphQL API. This is the getData function. It's an asynchronous function, so we have try catch. And these 3 lines is what's going on. Actually, really 2 lines. The first thing we do is we call api.graphql. So I mentioned you can call get, put, post, delete, or GraphQL. We're calling api.graphql. We're then passing in the GraphQL operation and the actual GraphQL operation. So we're actually passing in that GraphQL operation helper and the query. So this is async. So once it's returned, we'll have a variable that I'm calling talk data. And this talk data has a few different properties on it. So we can do pagination. So we have the data.listTalks. You can either call .next token to get the new item in the pagination for the next key, or if you just want the array of data, you can call items. So that's what I'm doing here. I'm getting that items array, and I'm calling update talks, updating this array with that array of the array of talks. If there's no data in your database, it'll just come back as an empty array. And then we're doing something pretty simple here. We're just mapping over all the talks, passing in the speaker name, the name of the talk, and the description. So what I'm going to do is just copy all this. I'm going to go into app.js. And I'm going to just save that. This is the code we just looked at. And now we need to run npm start. Does anybody know the shortcut for this? For code, for the terminal? No, I'll just do this. Control R? Oh. So let's go ahead and run this, npm start. So we now have 2 servers running. We have our GraphQL server, and we have our React app server. Notice I'll leave out any styling at all, because if we added styling, it would just be a lot of extra code, and we don't want all that stuff. So we'll see that the same data that we queried for here, these 2 talks, comes back here. So that's working. If we look at the data that comes back from our API, log to the console here, we'll see that we have a list talks array or list talks object and then a next token. The next token is null because there's nothing left in our database. We only have 2 items. So queries are working. The next thing we want to do is look at some mutations. So what we're going to do is we're going to add mutations, and we're going to then take like another 10-minute break or so. So what we're going to do now is refactor our use state into something called use reducer. And use reducer is very similar to Redux, if you've ever used Redux. What you end up having is a reducer, and the reducer is structured exactly like a Redux reducer. You basically have an action, and you have some state. You switch on the action type, and you update the state. So let's walk through all this real quick. Starting back at the top of the file, we're going to now import use reducer. And the reason I'm actually using use reducer, it's not just to be fun and fancy. It's actually because we're basically creating a WebSocket connection in the next step where we're doing a subscription. And we have a closure that's not going to work with use state. If you've ever done something like a set timeout inside of use state, you might have run into this issue before, and it's like probably the biggest complaint about hooks. It doesn't work at all. You have to take that state and move it into a reducer for it to actually work. So that's why we're starting with the reducer on this step, so it doesn't get super complex in the next step. So instead of importing use state, we're importing use reducer. We keep the same imports from Amplify. We have API and GraphQL operation. We're now importing a new component from UUID, And we want to create a unique identifier to identify the person creating the operation, because we need a way to identify who that user is. We don't have any authentication information. We want to have a representation of this client. We do that because when we create subscriptions in the next step, we don't want to subscribe to our own data changes. We want to be able to discard duplicate data. The only way to do that is to know who is the one that created the data. And one way to do that is by using something like this. And we attach this ID whenever we create a mutation. We then have another import for our mutation. So we're now importing our query and our mutation. The mutation that we want is create talk. We then create a client ID using that UUID library. That's a constant. We then take our state, our talks array that we had earlier right here. We move that into a state object that we're calling initial state. And we need a way to set state on a form. And we also need a way to reference those talks. And actually, when you get with this much state, it's not a bad idea to get used to using user reducer anyway, because you end up having just less code and stuff like that, I guess, polluting the main function. So we need a way to keep up with the name of the talk, the description of the talk, the speaker name, and the speaker bio. So we pretty much just set all of those to empty strings, and we create this talks array. So that's going to be our initial state. We have now 3 actions that we're going to be working with in our reducer. We need a way to set the talks when the data comes back from the API. So in the last step, we called API.GraphQL, and then we updated the local state by using that update talks function. Here, we're instead returning a new state using the existing state, and then we're just resetting the talks array to the new data that's going to be passed in from the action. So this action.talks is going to be the API.GraphQL response, where we called talkdata.talks.list.talks.items. So when we set the talks, we're basically just setting the talks array. We also want a way to set the user input as they type. The way that we do that is we have a set input action. We return the existing state again, and we have also the key and the value. So we're going to have a form. The form is going to be passing in something like description, value of the input, speaker bio, value of the input. So that's kind of what's going on here. We're setting this form data here. That's happening right here. And then the last thing we want to do is have a way to just clear everything, because when we create a new talk, we want to just clear out the input. The one way to do that is to just return all of that initial state, which would be these 4 empty values here, and then just taking the talks array and leaving that as is. So this is kind of a concise way to reset the state. So that's what's going on in the reducer. Now to use that reducer, we're going to call useReducer, passing in the reducer function and the initial state. The reducer is the first argument, the initial state is the second argument. And that gives us the state of this component that we can store in whatever variable we'd like to call. I'm just calling that state. And then we have a function that allows us to update the state that I'm calling dispatch. Anytime we call dispatch or whatever you call this, you can pass in whatever you'd like to. We're going to be passing in an object with an action property and whatever other properties. So you notice that we're switching on this action. When we call dispatch, we're basically just calling the dispatch function and passing in that object. The object is going to have a type, and then we're going to pass in whatever other information we want as the other values. So we also have the same use effect as we did in the last section, where we basically just have a component did mount, where we're going to then call the API. And get data, we call API.GraphQL, just like we did before. And then here, instead of calling update talks, we now just dispatch the set talks action. And then we set the talks set to the data coming back from the API. So this is a a lot going on here, kind of, compared to the last step. The last thing we want to look at is how can we now create a talk using the new create talk mutation. What is essentially going on here, we can kind of jump to this line right here. We're calling API.GraphQL with the GraphQL operation, and we're passing in the create talk mutation. And here, instead of just passing in one argument, we're passing in 2 arguments. So in the mutation, we need to actually pass in an input containing all the information about the talk. And what we do is we create a talk variable using all of the information off of that state. So we destructure name, description, speaker bio, and speaker name off of the state. We check to make sure that none of these values are empty. We then create a new variable called talk that contains all of that other state along with a client ID. We do an optimistic response where we basically create a new variable called talks, because we don't want to wait for that API call to return. We want to go ahead and update the local UI for us to do that. So we then dispatch 2 actions before we even call the API. We first set the new talks array, and then we clear the input. And then only after that is when we actually call the API. And what you would typically do in a real world app would be, in this catch block, you might have a notification that lets the user know that that action didn't work. And then you might even take that talk back out of that array and reset the local state. And then that's really about it. The only thing that we might go over, other than here, this is just some basic form stuff, is the onChange handler when we're calling set input. If you remember in the reducer, we have action.key and action.value. Here, and the onChange handler, we're passing in the key as the name of the input and the value as the value of the input. And here you see we have a name attached. That gets passed in as the target name. And we have the value passed in. That's not the value, actually. The value is coming in from the user typing. That's going to be this property here. So again, we should be able to go ahead and copy this. Probably going to run this server here instead. So now we have a beautiful form here. So let's go ahead and see if this works. So we want to go ahead and create a new talk. Oh wait, this is the name of the talk. All right, so now we go ahead and create talk. We see that the input fields clear out. We see the local state is updated. Let's go ahead and refresh to make sure that that's there. It is indeed. And now if we go back to our GraphQL server and we run the list talks, we should now see that we have our new mutation there. So the mutations are working, the queries are working. The last thing we want to touch on are subscriptions. And then we'll start getting into some more complex stuff around authentication and authorization. So I think now is a good time. We'll take a 10-minute break. Does that sound okay, you think, 10 minutes? Yeah? Okay. I know I was going kind of fast there, but I was really just talking over the code. Again, it's all copy and paste if you want to follow along. So we'll take a 10-minute break, and we'll be back at 5 minutes before the hour.
Ask on if anybody else
Yeah. Has anyone hit the error that says max retries hit for starting DynamoDB emulator?
Yeah, me.
Oh, you did hit that?
So it seems like Java is not installed, something
Yeah,
like this. I tried to install
So
it.
Java version or something?
So
Did you fix it?
there's a link to download it, but it didn't help.
Yeah, exactly.
So we restarted the machine, maybe.
Did that work?
I haven't tried, actually, it just followed you.
Yes.
If anyone does get that error and they want to follow along, they can just run Amplify push, which will also create the services in your account. And then at the end, you can just run Amplify delete to delete everything. So that's one workaround for now. Yeah. Or you can update the version of Java. I think someone had an answer for mocking API error.
So
Did someone have have a fix for that? What was the fix? Do you mind telling everyone here?
It's not my fix, so copyright is somewhere else.
Hey, Ham, for the fix.
So for the API mock error, it's brew cask install Java. It works. It's his fix over there.
I think the Java version just might be out of date.
No.
Because I'm pretty sure most people already have Java. Okay, so I think we're going to continue on, and we're going to try to get out of here within the next hour. So at 10 o'clock, we should be done with what I intended to get done. We're not going to finish the entire workshop, but I think we're going to stop it right before we get into Lambda function resolvers, which is kind of more advanced feature that we weren't really intending on covering, but it is all covered here. So, if you end up leaving early, or if you end up leaving and you want to continue on, feel free to continue on. But the thing we want to add now is subscriptions. And subscriptions are, the real-time aspect of GraphQL. The really cool part about what AppSync does is it allows you to set up some of this more complex stuff that you might have had spent a lot of time on your own managing and dealing with. We kind of do that for you. And before we continue on, let's take a look at some of the code that was generated, because a lot of the stuff we're doing now, if you're new to Amplify, probably seems kind of like magic. So let's jump into the Amplify folder and look at the backend folder and kind of get a better idea of what's going on. So in this backend folder, we're going to have a list of all of the different features that we've enabled as we start adding those. Right now, the only thing that we've added to this project is a GraphQL API. So you'll have an API folder with all the different APIs in that folder that we've created. Right now, we only have a single API. So you see that in the backend API folder, we only have this one API. If we added additional APIs, you would see a list of different APIs. So now we want to go into this API itself and see what's there. The main thing that we're going to be working with is the schema. So here is the GraphQL schema. We're going to be updating and modifying this as we go. Once we're ready to deploy this and we run Amplify push, you're going to see, or if we're running a mock, you're going to see that the build folder is populated as well with our resolvers that were automatically written for us and additional things that we can modify as we get more advanced. But essentially, in the API, conference API, schema.graphql, this is how you can continue to kind of update your schema and modify it as your app progresses. So whenever you want to deploy this, you would run Amplify push. Whenever you wanted to modify a field or add a new type or delete a type, you would then remove that from this schema and then run Amplify push again, and that would then update your backend. So we're not going to be touching this right now, but we are on the next step. I figured I'd just go over it. But what we want to do now is run our GraphQL subscriptions. So we're going to go ahead and do that. And we need to do three main things to make our app have real time. The first thing we need to do is import the subscription definition, and that is located at GraphQL/subscriptions. And we're going to import the onCreate talk, so we can subscribe to onCreate, onDelete, or onUpdate. The only thing that we're worried about so far is onCreate. We want to subscribe when someone creates a talk. We then want to add a new case to our reducer. The only thing that's changed in this reducer versus the old reducer is these two lines here. We add a new case for adding a new talk. And what we want to do is we want to take the existing state, we want to then take the existing talks and spread those into a new array. So we're just saying we want to take the old talks, drop those in a new array, and then add the new talk coming in from the subscription into that array. And we're using this in the reducer because we're doing we're basically going to have a closure here when we run the subscription. So we just do the add talk in our reducer, and then we have to go ahead and create the subscription. And we do that in use effect. And you can actually just copy this into the existing use effect hook that you already have. And what we're going to do is create a variable called subscription. And here we're going to call API.GraphQL, just like we've done in the past. Earlier we did API.GraphQL passing in a query, a mutation, Now we're passing in a subscription. The main difference is when you're passing in a subscription, it's not going to be an asynchronous or a promise. It's not going to be an asynchronous operation. Instead, we're going to then chain this .subscribe function to it. .subscribe allows us to specify a next function which fires anytime this subscription is triggered. So we're going to say when someone creates a talk, we want to call this next function. The next function gets the talk data passed in as an argument. And then it's kind of on us to handle that new data as it comes through. So say 100 people have this app open. Someone creates a new talk. We're subscribed to it. This next function will fire, and all of the other clients listening will then take this data, and we need to update our local state in some way. The way that we do that is we call the add talk. We dispatch the add talk type, and we pass in the talk that we retrieve off of this event data, and then that populates the array. Where does that data come from, or that talk come from? Well, event data has a value property which has a data property. And then from the data property, we want the onCreate talk, which is going to just be that single representation of the talk. It's just going to be that object that contains the client ID, the ID, and all that other information. We then check to see if the client ID is equal to the talk client ID, because we want to make sure that if we were the one that created this talk, we don't update that array again, because we created an optimistic response in the last step where we went ahead and assumed that this operation was going to succeed. We populate the array and we set state. If we created this talk, we're going to discard that talk. We're actually just going to return from the function. We're just not going to go to this next step. If we were not the one that created this talk, then we will update the array. So let's go ahead and test this out. I'm going to go ahead and copy. Well, let me start by just copying these one at a time. So I'm going to go ahead and copy the subscriptions definition, or the subscriptions import. And I'm going to go to the area where we've created the imports for the other mutation and queries. So I'll go ahead and paste that there. Next, I'm going to take this new case and add it to our reducer. And then the last step is going to be taking this subscription and setting it up in our use effect hook. So I'm going to go to use effects, go below get data, and just paste this in. And then if we want to have something like component did or will unmount, we can then return a function to clean up whatever listeners that we have. In this case, we have a subscription. So we're going to say subscription.unsubscribe. This is essentially what component will unmount does. Okay, so we save that. We should now have our subscriptions enabled. So to test that out, there's a couple of ways you can do it. I guess one way would be to trigger a new mutation from the graphical editor. I haven't tried this yet, but I'm assuming it should work. So I'm going to go ahead and go to create a new talk here. And if this doesn't work, I'm just going to create a new window and test it out. So I'm going to say Jello. And we're going to go ahead and create a new talk. All right, it works. So you'll see that as we create that new talk, we don't have to update the UI on the left. It automatically gets updated. So let's go ahead and now delete a couple of talks, because now we have a lot going on. So I'm going to go ahead to mutation, and I'm going to go ahead and list all of the talks, and we're going to go ahead and do the delete talk mutation. All right, so I've deleted all the talks. Now if I refresh, you should see that there are no talks. We go ahead and add a new one again so we can test out and look at the subscription happening again for anyone that missed it. We can create talk. We see that it gets updated there. So the subscriptions are working. The next thing we'll do is we'll look at how to add authentication now to our API, because right now anyone can access this. It's just an open API because anyone with an API key can hit it, and it's not very secure. So what we're going to start with is a very basic form of authorization. It's just going to be generic authorization, meaning if someone isn't signed in, they can't access this API at all. We're going to then go into fine-grained access control, saying that certain fields or certain people that haven't created a field or a type cannot access it. And then we're going to look at group authorization, saying if someone is like not an admin, they can't do these different operations, kind of covering all the different use cases around authorization. And we're going to do that using those GraphQL directives that we looked at earlier, like at model. We're going to be using the at auth. So to add authentication, we first need to have some type of authentication service or authentication provider. And again, if you've ever used something like Okta or Auth0, you're familiar with the idea of authorization as a service. We have something called Cognito, and that's what is working under the hood with Amplify. So to add authentication, we can just run Amplify add auth. And I'm going to go ahead and keep all my stuff open and just add this in a new window. So Amplify add auth. And I'm going to show a version of this. We're going to go, I'm getting ahead of myself, but someone created something pretty cool today. I'm going to show y'all. So Amplify add auth. We're going to go with the default configuration. You can do a bunch of different stuff at this point to configure your authorization to be how you like it, I guess. You can do things like set password security. You can set the MFA messages. You can set different rules around the passwords. You can ask for more metadata from the user by doing the manual configuration. But we want the default configuration since it's a workshop. We're kind of trying to go fast, make it easy. But the default configuration is actually shipped in a lot of production apps, even from in our enterprise customers. And what it does is it kind of starts with a smart set of defaults. So it gives you multi-factor authentication on sign up, and then username and password on sign in. So we're going to choose default. We can choose how we want the user to sign in. I'm just going to choose username. It's pretty intuitive. And then we can continue on with more advanced settings, or we can just choose no. I'm going to choose no and take what we have here, which is a pretty nice setup. So now we have this authentication service configured locally. In just a moment, we're going to need to deploy this. And we can either run Amplify push to deploy everything, but we don't really want to deploy our GraphQL API yet. So we'll look at how to just deploy the authentication. So to implement the authentication in our React app, that's kind of the next step. We're going to need to now use the with authenticator higher order component, which is something we're about to kind of take a look at now. And there's a couple of different ways to use this authentication service. So we've created the authentication service. We're going to go ahead and now look at how we can actually interact with it. We can use the raw authentication APIs from Amplify, which has 30-something different methods for calling methods like auth.signin, auth.signup, auth.forgotpassword, all that normal authorization stuff that you would want. We also have a few components that encapsulate a lot of this stuff for you to kind of get up and running quickly. And that's what we're going to use today, the with authenticator higher order component from Amplify React. So I'm just going to copy that and go to app.js. And we're going to go ahead and just go to the top. And under our last import from Amplify, we'll just now import this with authenticator. And this comes from Amplify React, not Amplify, because this is a React specific component. We then want to change our default export to be the with authenticator higher order component, passing in the app as the first argument. And we have a configuration object as the second argument. The configuration we're going to be passing in for right now is only a single property called include greetings. This gives us a greeting with our username and a sign out button. It's kind of an easy way to add a sign out button. You can also configure the styling and what is inside of this component within this configuration. But for now, we don't want to do too much. We're just going to go to the bottom and change the default export to be this with Authenticator. So I'm going to go ahead and save that and go back to the app. And what you're going to see once you save the app is that you now have this sign-in flow in front of your account. But before we can use it, we need to go ahead and mock the API again, because we need to actually be able to use that authentication service. And earlier we ran Amplify mock API. If we want to mock the entire project, we can just run Amplify mock. And this is going to mock not only the authentication, but also the API and anything else that we have, like Lambda functions. For us to mock the API, we actually have, the authentication service, we actually have to create this. And I think I mentioned at the beginning of this, we're going to be creating one service. That's this authentication service. So that's happening now. So it's going to ask us, are we sure we want to continue? We'll choose yes. And this is going to go ahead and create the authentication service. And while that's running, I wanted to quickly show you, someone tweeted out or messaged me earlier with something pretty cool. They took this with Authenticator component can be styled to look however you like it. Someone made it look pretty sweet. This is an example of it. So they took the with Authenticator added, I think it's like 5 or 6 different styles and made it look like this, which is pretty tight. So with 2 lines of code, you get the structure of this. And I think with another 20 or 30 lines of code, he made it look like this, which is the full username and password flow, which is pretty nice. And I think he tweeted out the code below this. Yeah, this is the code that made it work. So yeah, if you're interested in that, you can check that out. Yeah, so this is going to take a couple of seconds. I'm going to grab some more water while that's running. All right, so after the authorization or authentication service is created, then the new mock endpoint should go ahead and be opened up and ready for you to use. Before we look at that, and while people are maybe still waiting for their stuff to compile, how do you actually see the services that you're creating in your AWS account? Because now we're just all local. We haven't even opened our AWS console since we created the IAM user. If you ever want to go in there and look at anything, you can run Amplify console and then the name of the feature. So we only have authentication created, so I'm going to run Amplify console auth. This will go ahead and open up our authentication service in the exact place it needs to be, so you can actually look at stuff. The user pool is really what we're worried about. This has all of the users and stuff. So if you want to look at that, you can just run Amplify console auth. This will take you here, and once you sign users in and stuff, you'll see all their information here. But anyway, so let's go back now. We want to go back and look at our mock endpoint. Start off with the clean editor. And we want to go ahead and now use this authentication service. And we want to be able to now show how the endpoint is going to be authenticated in the next step. So let's go ahead and first create a new account. All right, so this is going to go ahead and create an account, and we should now have an MFA code sent to us via email to whatever email address you used. So you can enter the code here. And we should now be able to sign in. Okay, that's great. Our authentication is up and running, but our GraphQL API is still set to API key because we haven't actually changed that part. We've created the authentication service. How can we wire the two together? Also, you'll notice that we have this sign out button. This is from that second argument we passed to with Authenticator. What we want to do is we want to reconfigure the GraphQL API so we can run Amplify, configure API. And before I keep going, I just want to jump to the documentation to show that all of the stuff that I'm going over is in this documentation. I'm not really jumping ahead. I am skipping over a couple of steps because of time, but if you want to access the currently logged in users' data after they're signed in, you can run this code here, which is under accessing user data in between Amplify and mock and the step that I'm going over now. The step that I'm going over now is adding authorization to the GraphQL API. Amplify configure API. I ran that here. And now we can now choose the API we want to configure, and we can choose the authorization type that we want to set. So we already own API key. I'm going to now change that to Amazon Cognito user pool. So our GraphQL schema has now recompiled. If we run Amplify and mock now, we want to now test out, can we still access this endpoint if we're not signed in? Because we should not be able to, right? It's not set to API key anymore. It's now set to Cognito user pools. So if I refresh, the data is there. If I sign out and I go back to our app.js and I update the default export to just be the app and I refresh, we should now see that no data comes back. If we inspect, we should now see an error letting us know why we can't access the API. There's no current user. That means we can't access it. So if I go back and refresh that again and sign in, you should notice that the data does come back. So the data is there, but when we sign out, and we try to access it again, then we get an error. So our endpoint is now authenticated. That means that it's not open anymore for anyone. They have to be signed in. So so that's that step. So now that our API is authenticated, how can we start adding authorization rules around the person that's currently signed in? And that's what we're going to look at next. So what we're going to be using is the auth directive. The auth directive is really, really powerful. It's the second most powerful, in my opinion, most interesting directive that you can use. You can decorate a field or a type with auth, and then with auth you can pass in different rules based on what you want to be authorized about that field or that type. So one of the most basic things that you can do is just pass in rules and then allow owner, which means the person that created the field or the type is the only person that can read, write, update, or delete, or anything for that field. So typically what you see a lot of people doing for using this allow owner rule is either doing the full thing, just leaving it as is, because you need a field or a type to only be accessed by the user that created it. Or in a case of something like a blog where you want the data readable by the person that created it, but also everyone else, you can actually pass in another argument that sets different GraphQL operations to not have any authorization rules. So we're going to start with just allowing the owner to access a single field, and we're going to kind of like take that and make it a little more advanced. So the first thing we want to change is we want to add a new field called speaker phone number. And we want to maybe collect this information because we want to be able to communicate with the speaker because we're like running this conference. But we don't want this private information available to all of the people that are accessing the app. And maybe we want to only allow the person that created this to have that for now and have them the ability to also update it and things like that. So we're going to add this new field called speaker phone. So we'll go to our GraphQL schema and we'll add this new field and we'll save. You should see that you have the server re-updated with a live update. And we should now be able to go and look in our graphical explorer. And we should be able to now try to query the phone number from an old API. We should get, or from one of the old pieces of data. We should get errors because we're not the person that created that. So let's go ahead and just see what that actually looks like. So what I'm going to do is, I guess I'll go ahead and write this by hand. We'll go ahead and create a new mutation called create talk, and then we'll list the talks and try to get the phone number of the user. So now that we're authorized, we're mocking basically authorization through the graphical editor. There's now going to be an auth button here. And auth allows you to set a currently logged in simulated user. So right now it's set to user 1 and some basic email address. I'm going to go ahead and maybe change back to Dabit 3 and just came up with some email address. It doesn't really matter. And this, when you click generate token, it'll just generate the new token. So I want to go ahead and create a new talk. I want to include my phone number or the phone number, and I want to return all of this data back. And I'm going to start by not returning the phone number, and this should work. All right, so mutation. Now we're going to add our query. We're going to call list talks. We're going to just get maybe a few fields. We see that everything comes back fine. Now let's try to access the phone numbers for everyone there. You'll notice that we have an error, and anywhere that a speaker phone number should have been is null. And we're just letting the user know that we're unauthorized to access that field because we were not the one that created that. Let's now try to make a mutation to that field. Yes, this is for us. We created this one, so you're able to access what you created, but you're just not able to access what other people created, basically. So since we are the owner, we're able to access it. And we're going to look at next, like in practice, you would have two roles usually around something like this. You would have an admin role or a group role, and you would have an owner role because you want maybe an admin, like I am the conference organizer. I want to be able to see this also. But the user that created it maybe will want to have access to it to update their phone number if it changes or something like that. So you end up having an admin role, and then you have a user role for the person that created it. Well, actually, I'm gonna demonstrate the updating when we actually get to a type authorization, which makes a little more sense anyway. So, field-based authorization, we're basically just setting these auth rules on a field. Now let's look at more auth rules and also how to kind of change those auth rules. The next thing we want to do is how can we add authorization rules around an entire type? What we want to do next is we want to be able to have a way for people to comment on each talk during the conference. And we want to scope that comment to a talk in just a moment. But we also want to have a way for everyone to be able to read the comment, but the person that created the comment, only they can delete or modify a comment, right? Because that makes sense in the context of most comment mechanisms. You want to be able to have other people read the comments, but you don't want to have people that didn't create that comment update or delete. So what we're going to do is we're going to take that auth rule where we set allow owner, and we're going to add a couple of new fields to it. We want to add a queries declaration where we're basically setting the authorization rules to null on queries, which means anyone can now access all of the comments. And then we want to set who the owner or what the owner field is set to. And since we have a created by field, we want to go ahead and set the created by field as the owner field, which essentially means we don't have to actually explicitly pass in the owner into the argument. It's going to be read off of the claims set in the JWT that's passed over the wire. So it's a very secure way to basically set ownership, because we don't want to have someone be able to create a comment for someone else. We want to make sure that the logged in user is the actual one creating that comment and setting that created by field. So we're reading the created by off of the JWT for the signed in user essentially. So let's go ahead and copy this schema and add it to our existing schema. And for right now, I might just go ahead and remove this speakerphone, or you can leave it. The only thing, if you save it now, it's going to cause an error for the current data that you're reading in your React app, because we are querying for all of the data, including the phone number. So I'm going to go ahead and save that, and we should now see that the server updates. And now let's go ahead and try that out. So I'm going to go ahead and read all of the talks, and I'm going to go ahead and remove the phone. Some error. I think this is it. Might just do this. I don't know. Oh, speakerphone, that's what it is. All right, so we have two talks. Let's now create a comment on one of the talks. Well, actually, for now, we're not even worried about that. Let's just create a regular comment. So let's go ahead and go to mutations. And we'll do, let's go ahead and refresh this. And we want to go ahead and create a new talk. So we're going to create comment. And we'll add a ID and a message. Actually, we'll just add a message. And we'll return the created by, the ID, and the message. So the only argument we're passing into the create talk is the message. We'll call this great talk. And I'll go ahead and create that mutation. So that's our first comment. I want to now sign out and sign in as a new user. So I'm going to change the JWT to be Dabit4. And now I'm going to say, awesome talk. So I'm creating two mutations. Now we want to go ahead and list all of the comments. So I'm going to do a query for list comments, and I want to return all of the information. So we're able to read all of the talks. Now let's try to update the talk for the person that we are not. So I want to update the comment for Dabit3. So what I'm going to do is go to mutation. I'm going to go to update comment. And I'm going to return ID, message, and created by. So the ID is that. And I might add a message that says something rude, like this talk sucks. And if we run mutation now, we're trying to update someone else's comment. And when we do that, we see that we have an error that says the conditional request failed. This is basically saying that we are not the owner of that. So let's go ahead and run another query and update the talk or the comment that we created. So we'll change that field to be the ID of one of the comments that we created. And when we run that, we see that that actually succeeds. So now if we list all of the talks, the talk that we updated, or the comment that we updated was updated, but not the comment that we didn't update. So what that basically did is it allows only the owner to update, delete, or change, and it allows anyone to query, and it sets the owner field to be the person that's currently logged in. And if you see that we have Dabit 3, we never passed that in. It was kind of just read off of the token. The next thing we want to look at is how to now take the talks and the comments and have those relationships built in. We want to be able to say, we want to create a comment for a talk, and then we want to run a query that lists all of the comments and the talk and all of its comments, essentially. So the way that we do that is we add a new field on talk called comments. This way we can query for the talk and the comments for the talk. And then we take a new directive called @connection, and we set a name that references the talk property that we're going to be kind of associating with the comment. So we add two new properties, really. We add two new properties. We add this comments field on talk, and we add the talk field on comment. And we're setting the @connection to be referenced as the same on each one. So now when we save that, we go back to our GraphQL schema and we save that. We're going to now delete the old database, the old data that we have locally, because what we're essentially doing here is we're adding a secondary index to the comment database, and it's not going to work with our old data. So I'll go ahead and run this command here. And all of the mock data is in the Amplify folder under this mock data folder. And anytime you want to clean it out, you can just run, you can just delete that folder. So we deleted that. Now let's go ahead and run the mock command again. This will generate a new database with all of that stuff for us. And I'm going to go ahead and copy these operations, and we're going to kind of just paste those in to help us go faster. So what I want to do is create a talk, create a comment, and then list all of the talks. So I'm just going to paste all this stuff in and walk through it. Creating a talk is the same thing that we had done before. We're now being able to create a comment on an individual talk by taking the ID of the talk and passing that in as the argument for the comment. And here we have a field called comment talk ID, and that allows us to create a comment for that talk. And now we can list all of the comments from a single talk by calling the list talks query, and we now have a new field on the items array called comments. And then here we can get all of the messages for that talk. So I can go ahead and create another message, another comment. And when we list the talks, we now see that we have the comments. So we now have an association between the talk and the comments. The last thing we want to look at is group authorization. And this is like the combination of group authorization and fine-grained access control is really the sweet spot for most applications. What you typically want is a way for some type of administrative access. So how can we add that? Well, since the authorization roles is an array, you can kind of add more than one role to each auth type. So what we're doing right now is just setting a single role, but if you wanted to allow the owner and allow admins, you could do that. Or if you just want to let admins do this, in the case of a conference app, this is what makes the most sense, is we only want an admin to add a talk, right? We don't want any logged in user to be able to do that, but we do want any logged in user to be able to create a comment. So that's what this schema allows us to do. It allows only people that are in the admin group to be able to do anything as far as creation is concerned, but allows everyone to read. So instead of saying allow owner, we're saying allow groups. We then set an array of groups. This groups array can either be set here, or it can be referenced from a field coming from the database. So if this groups array is dynamic and you have it stored in your database, you can instead set that here and then read it from here. The last thing we want to do is make sure that all the talks are readable by anyone. So we set queries to null. And then we are ready to go. So we set this comment type has the same as what we had before. So we should be able to go ahead and copy this new schema and update it. And we should be able to go ahead and refresh. And what I want to do is go back to here, try to create a new talk. And if you look here, I am not an admin. So when I try to create a talk, I get unauthorized. I'm not allowed to do that. I want to now turn myself into an admin, so I can go ahead and set a group here by just setting the group name I would like to be a part of. I generate a new token, and then now, I should be able to create a new group. I wonder if there's something going on. I think I need to remock the API. So maybe I do need to remove that again. No, I think I've removed it already. Let's try that again. I guess I do. I think that might be what I need to do. Well, no, that wouldn't make sense. But let me try that. No, I'm pretty sure you should be able to, but let's go ahead and try that again. Yeah, there we go. Yeah, it must have been something in that old data. So I'm allowed to create one now. Let's go ahead and remove the admin and make sure that this is all working right. So I think I know what it was. I created one with this ID already. And I was trying to write to the same ID because I wasn't using a dynamic ID, which is what I should have. Okay, so now I should be able to not create another talk, unauthorized. If I go back and make myself an admin again, then I'm able to. So I think the error for sure was I was basically trying to write over an ID where we already had the ID. So I guess if we want to keep going, I know we're going kind of fast, and a lot of people haven't been going along. But the last thing, maybe since we have another 15 minutes or so, we'll go over Lambda resolvers, and essentially what we're able to do here is instead of what's happening right now is our resolver is talking directly to DynamoDB to a database. What a lot of times people are doing is having a third-party API, or you want to do something in a function and you don't want to be tied to a specific data source. You might want to do a lot more there. We can set a Lambda function as the resolver, and that's kind of what we're going to do here. So we're going to add a new Lambda function. We're going to then write the function code, and then we're going to then test it out, and then we should be kind of there on time. So what I'm going to do is go to my project and run amplify add function. And here we're going to be walked through what we want to do. I'm going to be creating a cryptocurrency API using a existing REST API. So we're going to basically have this GraphQL query run with some arguments maybe, hit a REST API, and then return the data back through GraphQL. I'll call the same thing as the name of the Lambda function as the local reference to it. We can then choose a template similar to our GraphQL schema. We can start off with whatever we'd like. We're just going to start off with the hello world function. And we can access other resources using this function. So for instance, if you had some other services enabled, DynamoDB, you could reference those, but we don't, so I'm going to choose no. And then I'm going to go ahead and choose yes to edit the function, and this is going to open up the function in our editor. And what we're going to basically be doing is we're going to be calling the CoinLore API. And what we're going to do is basically have a API call to that CoinLore API, and we're just going to return the results. We're then going to also have the option to pass in a start and a limit. because this is just going to be getting a list of cryptocurrency data and returning that array. But if we want to have a certain part where we want to start in that sequence, so we don't want to start with the first most popular one, we maybe want to start on the 5th or the 10th, we can do that. And then we can also pass in a limit. The limit is default 10. We can pass in 100 or 1 or whatever. Pretty basic stuff going on here if you actually look at the code. So we'll go ahead and save that. This is our Lambda function. You'll notice that we're using Axios, and by default, Axios is not available in the global scope of a Lambda function. So we end up having to install that in the function. And to do that, I'm just going to go ahead and copy this command. We're basically going to change into the folder where the source code lives. Whoops. Let me copy that again. We're going to go ahead and add Axios. Oops. And then we're just going to change back up to the top. All right, so now we've installed Axios into our Lambda function. We're going to now update our schema. We're going to have a query called getCoins, and the data returned from the coins is going to be a type of coin. There's a bunch of data that comes back from CoinLore, but the only thing that we really want is the ID of the coin, the name, the symbol, and the price in US dollars. You'll notice that the response that we're getting has a couple of different properties on it. We're only returning the data property. There's a bunch of other things that you can return with. The data property is an array, and we're going to be basically saying we want this array to be of type coin. That's why you have this array property here. To make this actually work with the Lambda function, we're passing the @function directive, and we're setting the name of the function as currency function, because if you remember earlier, when we created this function, we called it currency function. And then we're able to pass in a dynamic environment, because a lot of times what you're doing is you're working with multiple environments, and you want to be able to test this out and not have to set a hard-coded environment. So we're basically reading that environment variable by passing in the $$env. So I'll go to our schema. And add the new type of coin and the new query. All right, that's about it. So we'll go ahead and mock this again. I think it should work without me having to, I must have turned the server off. All right, so now what we're doing is we're mocking the Lambda function, and we're mocking the GraphQL API. So the query that we want to run, I think I might have it listed out here. We'll call the list coins query. Or is it get coins, actually? So get coins right here. For now, we're not going to pass in anything. We'll just return the ID, the name, the price, and the symbol. We see that we have this data. This is coming back from the real CoinLore API, which is cool. The next thing we might want to pass in is a limit. So right now we're getting 10 coins back because that's the default that we set. Let's say we only want to get 2 coins back. We get 2. Let's say we want to get 100. We get 100. Right now, when we get the 10 back, we'll notice that it starts with Bitcoin. Let's say we wanted to jump to like the 10th coin. We could also pass in a start of like 10. And we'll notice that we're now jumped to Monero. So that start and that limit was set again right here in our Lambda function. Pretty basic Lambda function. All we're doing is saying axios.get, passing in the CoinLore API. We're working with a separate outward-facing API. The last thing we might want to do is just deploy this. If you want to, you run Amplify push, and then you're able to have your API, deployed in your account, and you're able to interact with it. I'm not going to do that step because it's really kind of unnecessary. Nothing is going to change as far as what we've looked at today. So the only thing that you might be interested in is like where this actually AppSync API would live once you deployed it. If you did deploy it, you could just run Amplify console API. There's a graphical editor there. You can play around with it. When you're done with all this stuff, we can run Amplify delete, and this will delete everything. It will delete, the CloudFormation stack. It deletes your databases. It deletes pretty much everything. So yeah, and I think that's really about it on the workshop. I appreciate you all, staying a little later than we thought and being patient. And if you have any questions, reach out to me online, and I'll also be hanging around here for the next 15 or 20 minutes or so. So that's it. Thank you. Oh, and I guess I'll take a few questions real quick if anyone has any questions. Yes? Offline support is actually, so there's something I really should have covered and I didn't cover. We have two GraphQL clients. The client that we use is Amplify. We also have a kind of like a fork or a same API as Apollo and a different client. So what we use is the Amplify client. There's also something that we made specifically for GraphQL called the AWS AppSync client. It works perfectly well with all the stuff we just did. It just has the Apollo API. And in that client, we have offline support built in, and we also have caching built in. So basically, and we're working on adding offline support to Amplify. So that's going to be pretty badass when it finishes, but we're still working on it. But for now, if you want offline support and you are okay with Apollo, then you can use the AWS AppSync JavaScript SDK. Yeah.
Thanks for coming. So don't forget to return the badges, please. And if you can help us with collecting the photos, that would be nice. That we can get home soon as well. Thanks. And thanks a lot for your work. Very, very much.
Yes. Great to be here.